Hello everyone. In previous video I talked about Kademlia and the elements of the Kademlia node and how network initializers and peers connect to each other. And in this video I'm gonna show the sample code of a Kademlia API. So this is the Kademlia API I wrote in Java, and it's pretty much abstract. So you have to implement all the parts of the Kademlia node that I mentioned. Let's go over the layers first, and then I will go to the code. So there's a connection info. As I said in previous video, you need some connection info, which can be just simply an IP and port, or it could be HTTP information, HTTP address. For example, it could include some paths or anything. Every node has its own connection info, and other nodes use this connection info to contact this node. Then after that, every node has a node connection API. So you have to implement this API in order to let your node connect to other nodes, send requests to other nodes. And when you send a request, you need a reply from those nodes. So to receive replies from other nodes, you have to implement the node API. And we will see what that is in a moment. So, for example, a node connection API could be implemented with a HTTP requester. For example, it could be HTTP client from Apache. And the node API could be just Tomcat. For example, a Spring Boot on the Tomcat to receive some HTTP requests. Then you have to determine your routing table, and these are all of the elements that you have to take care of. So let's take an overview over the usage of Kademlia node using this certain library. In order to create a new Kademlia node, you have to create an instance of Kademlia node, pass the ID of the node and the routing table, and the connection API implementation, and also you should pass the connection information of this current node. If your node is supposed to store some data, then you should create an instance of Kademlia repository node. And at the end, you have to pass an implementation of repository, which we will see the interface very soon. Or you could just use Kademlia sync repository node, and soon we will see the difference between these two. So what is important here is that using this API or using this library, you can choose between having a Kademlia node without any storing data, or having Kademlia node that is capable of storing data. So I'm going to open my IDE and create a new project. Let's call it Kademlia example, and I'm not going to change this, doesn't matter right now. And we can see my project here. So this is a Maven project. Now I'm going to have to add a dependency. The dependency I'm going to add is this Kademlia library, and here I wrote how to do that. First, we're going to add Jetpack repository because I'm using Jetpack to host this Maven project. So let's add that one, and then we can add the Kademlia API repository. One last thing is that I'm currently on version 1.3.9, but this is the old one, so I'm gonna update it to the new one. you can always find the latest version here at the top, or you could just go to the releases and see all the released versions, and I write here that what's the difference between each version, so you have to change log. So in order to create our first Kademlia node example, we have to use a Kademlia node object or class. Note that this class is generic and it accepts ID that should be a number and C, the generic type of C, which should extend connection information. And I told you earlier that what this connection information is. So first thing that I'm gonna do is to create my connection info, and I'm gonna make it implement a connection info. This is just a serializable class, it has nothing more. So based on your own implementation, you're gonna use this class, my connection info, in all of your application. For example, this could include something like integer, port, and a string address. But in this example, I'm not gonna add anything to it. So I'm gonna say the ID of my node is integer, and the connection info is type of my connection info. So as I said earlier, I can create instance of these three types of Kademlia node. And for now, because I'm not going to use storage, I'm just going to use this one, the simple Kademlia node. So let's see what constructor parameters are. First, it's asking me the node ID, and it should be integer. Then it's looking for a routing table. That routing table has an integer ID, again the type of connection, and buckets. These buckets are used to store the list of other nodes that this routing table or this node knows of. And this is the concept that we've been through in the previous video. Then it needs the node connection API, and it's gonna use this one to connect to other nodes and request to connect to other nodes, and at last it needs its own connection info. I mean the connection info of this current node. So to help us to go through this video a little bit faster, I'm going to use some of the objects that I have written in the test part of this application here. As you can see, I've just implemented empty connection information, LocalNodeConnectionApi, which is used to contact the other nodes that are in our local system or in the same application that we are using for test purpose. And here I'm gonna use some simple repository. This is useful when we are using a storage type of the Kademlia node. So I'm gonna import these classes into my code right now, and we will go through them and see how they're working very soon. So let's do that. And yep, empty connection. Yep, now it's working. Perfect. And I don't need this one anymore. So this will change to empty connection info. Now let's go over the parameters one more time. First, it's asking for node ID. I'm gonna use 0, and then it's going for a routing table. I can create a new integer routing table, pass the ID. Then it's asking me for node connection API. I'm gonna create a new local node connection API, and it's again asking me for this current node connection information. So I'm gonna use this. Let's make it a little bit cleaner. Okay, good. So now I have my first Kademlia node, and we can call it a bootstrap node. So let's see the available methods on this bootstrap node. So I can get the routing table. This is exactly the one that I passed to the node right here. I can see if the node is running. I can call unpinged. So this is a listener. If this node is supposed to be pinged, I can call this unpinged. I can get the reference nodes. I described what the reference nodes are in the previous video. These are the nodes that this node, the bootstrap node, has chosen to keep the persistent connection to them. I could start or stop this node. I could bootstrap this current node with another node, and we will see this very soon. Or we could get the listener, we could get the connection API, which is exactly the one that I passed here. And these are the other parts of the listener, and we will see soon how to call them and why to call them. And those were the important ones. What I have to do right now is to start this node. And right now this does nothing for us, but let's see if it works. As you can see, the application is not exiting, because when you call a start on bootstrap node or any Kademlia node, there is a thread and the application is attached to that thread. So as long as this node is running, the application won't stop. And we can see it here. I call the stop and yep, throw it. Now if I restart, it's gonna start and stop right away. So right now we have created our first bootstrap node. I call it the bootstrap node. So the ID of this node was 0. Now I can create another node, call it Kademlia node 1, and pass the ID of 1 to this node. So this is my second node in the ring. What I'm gonna do with it, I have to bootstrap this node using another node. So you can see this bootstrap function here. What it needs from me is to pass a node that has integer ID and empty connection info as the connection info. So I'm gonna pass the bootstrap node to my second node in the ring, or Kademlia node 1. It may throw an exception. I'm gonna let it stop this application if the exception is thrown. It's a bootstrap exception. One thing to note here is that I'm not gonna need to call a start on this Kademlia node number 1, because I'm calling the bootstrap method. As you can see, at the end of this method, I'm calling the start method myself. So I have already explained what this bootstrap method does. It basically asks the bootstrap node for all the close nodes that it knows to this current node. So let's see what happens when I run this. I get error and it says that it failed to contact the bootstrap node. And the reason is this LocalNodeConnectionApi. As you can see, in order to have all the nodes here, I have to register them to this object. So what I have to do in my example is to create only one instance of this object. And use it everywhere. And after I run each node, I have to register that node in this local node connection API. Let me change the name. So I'm going to register the bootstrap node here. It should be integer. Yep. And now the Kademlia node. Now let's run the application again. So this is from the local node connection API, and we registered these two nodes in the local connection API. So next thing, we would want to know that if bootstrap node is part of the Kademlia node 1 routing table, and if Kademlia node 1 is part of bootstrap node routing table, we want to check that. So I'm gonna create a simple helper class. I'm gonna return the node IDs. Kademlia node that is passed to this function. So what I do here is to get the routing table, get buckets, and for each bucket, oh no, for each bucket, I'm gonna get the node IDs and add them to some already defined list. So I have this node IDs list here, and I'm gonna add all of these and then return the node IDs. So I can print the node IDs of the bootstrap node, also the node IDs in Kademlia node number 1. Let's see what happens. So as you can see, in the bootstrap node we have 0 and 1, and also in the Kademlia node we have 1 and 0. The order changes because the 1 is closer to itself, to this node, and the 0 is closer in bootstrap node to itself. So let's move on to our second example and see what else. So now let's move on to our second example. I'm gonna create a copy of this one and call it 2. Okay, so there is a class called common, and it has some of the settings that is used in Kademlia API. One of the most important ones is this one, the identifier size. So I have described what the identifier size is in previous video, and in this video I'm gonna use the identifier size of 4. This means that we have 2 to the power of 4 nodes in our system. Now I'm gonna remove this and this method for now. The next thing I'm gonna do is to, instead of creating only one other node, I'm gonna create all the other possible nodes. So I'm gonna create a loop, and I'm gonna start with the node 1, and I'm gonna create nodes till the common identifier size 2 to power of common identifier size has reached. So for these nodes I'm gonna call it the next node, which is the next node after the bootstrap node that is being created. I'm bootstrapping the next nodes using the first node. Also, I'm registering the node in the LocalNodeConnectionApi. I can first register it, then bootstrap it. It's totally fine. Now, before I continue, I'm gonna show one other thing that we could add to our nodes. So let's say we have bootstrap node. I can set a listener on this node, and in the listener, which is a subject object, and in the listener I could have implemented any of these methods here, and you can go through the documentation or even the code and see what each of them do and when each of them is called. But for now I'm gonna override this certain method, which is called onReferenceNodeUpdate. Let's see when this is called. To show you when this certain method is called, I'm gonna show you the source code of the Kademlia API. So this is the source code, and there is this method called makeReferenceNodes. So when this method is called, we get all the possible distances in our key space, and for each distance we're gonna find the closest nodes in our routing table, and then we're gonna add them to this list here, which is a local property of this Kademlia node object. And after that it's gonna call the onReferenceUpdate method from the listener. So let's see when this function is called. As we can see, this is periodically called after the node starts. And to control how often this is called, there is this setting called reference_node_update periodic seconds, which by default is 30, and that means that every 30 seconds our listener is called and we get the reference nodes. And this is also part of the common object or the settings. So let's get back to our code, and I'm gonna change that setting, and I'm gonna set it to a shorter number, maybe 2. And what I'm gonna do in this listener is to add all of this information to a map. So what I'm gonna do next is to create a map of integer to list of nodes. So the key will be the ID of each node, and the value is the list of the other nodes that each node is referencing to. So this is how I'm gonna update my map. This Kademlia node that is included in the listener is the node that we registered this certain listener on. So for example, I'm registering this listener on Bootstrap node, and this Kademlia node is the Bootstrap node. This is helpful because we can later use this listener on all the other nodes. And let's do that. I'm gonna cut this to here, create a new instance, and I'm gonna move these here. So I'm gonna register this listener on this Bootstrap node before I start it. So I make the Bootstrap node, register the listener, and register the Bootstrap node in LocalNodeConnectionApi, and then I'm gonna start the Bootstrap node. And I'm gonna do the same thing to all of these other nodes that I make here. So instead of Bootstrap node, I do the next node. So this is nice, but just remember that every 2 seconds this is gonna be called. So now what I do is to sleep for like 3 seconds. This can be interrupted, it's okay. And after that I'm gonna print our map, this map that we are adding the node IDs and reference nodes, the map. Let's run this and see what happens. So I made a mistake here. I have to change this one to I to increment the node IDs. So let's run this one and see what happens. So it registered all the nodes, and now it gave us a really good response. Let's see what we have here. For example, it's saying the node 0 knows about node 1 with distance 0, node 2 with distance 0, 4 with the distance 0, and 8. And we have exactly saw the same thing in the previous video. Also note that these are not the only nodes that are available in node 0 routing table. These are only the one that node 0 is choosing to keep the persistent connection to them. And we can see for all the other nodes here as well. Node 1 knows about 0, 3, 5, and 9. This is exactly like the previous video. So what I'm gonna do here is to create a new function. So what this function does is to get a list of reference nodes and checks if certain node IDs are available in this list of nodes. And because of that, I can write something like if list contains all map.getNode0, and then pass the ID of the nodes that I expect node 0 to have persistent connection to, which are 1, 2, 4, and 8. And I have done this for all the other nodes. And when I run this method, when I run this main method, I'm gonna have to see all the true values here. Let's see now. Wait, and yep. So if this was a test in Java, you would have used assert true, but right now this is enough for us. So what we did here was to create all these other nodes and bootstrap them using the bootstrap node. Using the bootstrap node, yeah. So we're gonna change that. I'm not gonna make any change to this part of the code. So at the end of this example, we still need the node 0 to know or keep reference to these nodes. But what I'm gonna change here is to, instead of using the bootstrap node in all the other nodes, I'm gonna use the previous node. So to make it more clear, I will have a previous node, which right now is the bootstrap node, and I will always bootstrap using the previous node and update the previous node to the next node, or we can call it the new node. So what happens here is that node 0 starts, node 1 wants to join the ring, and it uses the node 0 to bootstrap. Then node 2 wants to join the ring, and that one uses the node 1 for bootstrap, and the same goes on for the other nodes. Let's see if this still works. We gotta give it 3 seconds, and yes, it's still working. And that's the beauty of the Kademlia API or Kademlia algorithm. So no matter which node you choose for bootstrapping, you're gonna have the same result. So I've made a little change to this method here. First, let's run this again. I think this is more clear now. I'm extracting the IDs from the reference nodes into the reference node IDs, and I'm gonna see if all these other past node IDs contained in this list. So this is still true, but let's, for example, say the node 0 had to know about node 10,000, which doesn't actually exist in this ring, but we just want to make sure that this returns false. And I'm gonna refresh it, and yep, it's false. Also, let's move this to the previous example. And please don't mind that I'm copying this code. This is just an example to show how this thing is working. I know this is not a right way to write codes. And this one is still all true. So now let's go for another example. What I'm gonna do here is to store some data on this node system. So instead of Kademlia node, I'm gonna create Kademlia repository node. Yeah. And it needs two more generic data from me, the key and the value. So it needs to know what is the type of the key in this repository and what is the value type in this repository. And what I'm going to do here is to use the one from here. It's going to be integer to string. So integer to string. And what it expects me here is to pass a repository. So I'm going to create a new instance of sample repository. Yeah. And I'm going to do the same thing for all these other nodes. So first I change their name, and this shouldn't be 0, this should be I. Sorry, I. So first let's see that this doesn't change the behavior of finding nodes in the network. So I'm gonna run this to make sure. Yes, we have to remove this, but still, yeah, all the nodes in the network know each other, and that's good. So the next thing, so instead of this thing, or instead of this, I'm gonna try something else. So now let's see the DHT part of the Kademlia algorithm and this API that I wrote. Let's say, for example, I want to store some data in the DHT. So I choose any random node. This time it's bootstrap node, but it could be any other node. And I will call a store function on this node. The key would be, for example, 5. The value can be hello world. So what I did here, let's remove this one so you know that this store function can throw an exception if it can't store anything in the network. But it also returns a store answer. And in this answer, I've got something called result. It's an enum. And let's see. It either stores the data, and if you get a stored result, it means that the current node, which is the node 0 in our case, or the bootstrap node, has stored the data itself. It may pass the data to other nodes. It may fail, or it may get a timeout. And let's come back here. Let's see what happens in this example. Also, I'm gonna say the result is this. I have already ran this, so there's no surprise. The result is passed, so it means that the bootstrap node didn't store this data itself. It has passed it to other nodes, and some other node has stored the data. But so let's see where these two other prints come from. These are from the LocalNodeConnectionApi, and as you can see, I just printed something here. We can remove that so it wouldn't affect anything. It's still the same result. Yep, it's another print. It's okay, never mind. So let's try and read this data from the DHT. And to read the data, I'm going to use the final node, which is this one. And of course, according to this loop, the node ID of this node, the previous node, should be 15. To make sure, I'm gonna print that and say using this node to get the data, and then I'm gonna call previous node get 5, and the get answer. Also, the get answer throws the get exception. So for now, let's see what get answer has. I'm gonna print a result. I'm gonna change this to a store result and change this one to get result. And I'm gonna run. So both of them has the value of past. What this means that also node 15 didn't know anything about the key 5, so it has passed the request to another node to get the result. And let's see if the value is here. The value of the get result, I'm gonna type value and restart this. It tells me the value is null, and this has a certain reason. One thing that you have to note is that we don't get blocked behind these functions, the store and the get function, but we are sure that it takes some time for the data to get stored in the DHT. So let's go back to this listener we had here, and let's review some of the methods we could override. As you can see, there is a on key lookup result and on key stored result here. Let's override them. And first, let's go after on key stored result. This method is called when a certain node stores the data in its repository. So to know that which node has stored the data, I'm gonna try and use maybe this node dot get ID. This is the ID of the node that stored the data. Then I'm gonna say a stored value for key, and it passes me the key here. So I will have node X stored the value for key X, and in our example it's 5. Let's come here, and now we can say node X has passed us the value of key X, which is the value, and the value is passed here. So on key lookup result we get the key and the value, and on key store result we get the key and the node that stored the key. Note that these only get called if we use these functions. So this is one way to do this, and we will see the other way soon. For now, let's do this again and see what happens. So this is very beautiful now. Node 5 has stored the value for key 5, which makes sense because the distance between 5 and 5 is absolutely lower than the distance between the key 5 and the ID of our node, which was bootstrap node here when we were storing the data. And then we move to node 15 to get the data, and it says node 5 has passed us the value of key 5, which is hello world. So we could retrieve the key and the value, and we could store the data, and as you can see, the data is distributed, and that's good. So this is nice, we can do this, but there is another way to get these values, an easier way. Let's move to our next example, and I'm gonna remove this. Instead of using the Kademlia repository node, I'm gonna use Kademlia Sync repository node. I don't need to make any changes to the constructors. And same here and here and here. Yeah. Let's see about the store answer. If I remove this, yeah, it's the same, that's fine. So a store answer doesn't have anything else. The key, the result, the node ID. I don't think it affects the node ID here, but we can try. But if you remember, and it's not removed, the value when we were retrieving the data from the DHT was null before, and now this time it shouldn't be null because I'm using the sync repository node. And let's see that. I ran the wrong class. Let's run this one and it should work. Yeah, as you can see, now we have the value without using any listeners in our Kademlia node listener, and this is nice. And what we could do here was to give it, for example, 1 second to give us the value. Otherwise, if this time passes, the result here would be timeout. As you could see, you would get timeout. But if we don't use sync repository, we either only get success or we get passed, and this makes sense. So maybe if I choose if I remove this, and if I choose like, I don't know, 1 millisecond, 10 millisecond, this may be timed out. Let's see. I can't be sure, but we can just try that. Yes, it got timeout. So we didn't give this node enough time to retrieve the data from other nodes, and that makes sense. So I've been using this LocalNodeConnectionApi through this video a lot of times, and I'm going to tell you what it does exactly. It's really simple. It's implementing the node connection API, which I describe it here. It was used to send information out of the nodes. So for example, let's say we have a bootstrap node and it wants to, or we have node X, it wants to send a ping to node Y, and our node X has an implementation of this node connection API, and it calls this ping method, passes itself. So if the node X is calling this ping, this color would be X, and also passes the node that it wants to ping as second parameter. So this would be y. X is pinging y. And in this local node connection API, because I have access to the reference of this second node, I am calling the ping method on that node. But this is not the case if you are gonna implement all of these in a production code. You gotta have to implement the node API to retrieve the data that is sent by node connection API, and then there you could call this onPing method in your implementation of node API. So the last thing I want to talk about is common attacks to Kademlia network, and I'm gonna add the link to this article, which is really helpful, in this video description. As you can see, there are mainly two types of attacks to Kademlia network, and you can pretty much protect yourself from these attacks by single simple approach, and that approach is pretty much described here. But to make it short, you can imagine that each node has a private key and a public key, and you can create a challenge. So if a node wants to join a network, it has to prove that it has passed the challenge, and that challenge can be having, for example, 4 zeros at the end of SHA1 hash of the node public key. So the node has to create a private key and public key, and the public key, when it gets hashed with SHA1 algorithm, it has to have 4 or, for example, 3 zeros. So we can make sure that it takes quite some time for the node to find this public key, and the node has to sign this public key with its private key to prove that it owns the private key and it has done the challenge, it has passed the challenge, and pretty much the hash of that public key could be the ID of the node. So we will be sure that a node cannot generate too many identities and it can flood the network. So thanks for watching this video. If you don't want to use my API, or you want to create your own Kademlia API and try to see if you understood the algorithm right, you could see my code. It's always available in EP2P, Eleuth P2P, and Kademlia API, and I'm always trying to update it and fix the bugs. And make sure you also see the links that I added in the acknowledgement. There are great tutorials and great codes by many other good programmers in the internet, and you can see their work too. And make sure to subscribe to this channel for more incoming videos on Eleuth P2P and Kademlia API. Have fun and take care.